Hey guys! In today's video we are going to take a closer look at procedurally generating low poly terrains. Most commonly people use a plane as a base for terrain generation. If we look at the WIREMESH, we can see how everything is spaced very evenly, and if we visualize the vertices of the plane's mesh, you see that this is in fact a perfect grid. Since we want to achieve a low poly look, we want something that has more uneven spacing, so let's just place the vertices completely random between a max X and Y position. This will do for now, and we can jump into triangulation. One thing I knew is that I didn't want to write that part of the code myself, so I did some research and ended up using TRIANGULATION for its DELAUNAY triangulation. What is DELAUNAY triangulation? Great question, I'm glad you asked. To explain it very briefly, it is an algorithm that creates a net of triangles within a plane where none of the points you give as an input is within the circumcircle of any triangle of the net. I'm not going into more detail than this in this video because we have a lot of other stuff to cover, but let me know in the comments if you'd like to see a video about it and maybe I'll make one. So, in my terrain generator class, I'm creating a bunch of points at random positions which TriangleNet then uses to create a triangulated mesh for me, which in turn I can then turn into a unity mesh and draw it in the scene view. To generate the mesh, I'm looping through all the triangles of the mesh TriangleNet created, adding them into lists of triangles, vertices, normals and UVs to then populate a new mesh. To visualize the triangles better, I decided to add random colors per triangle and ended up with what I'm calling my little church window simulator, patent pending. If I now increase my point density value, I can get a much finer layout of triangles. However, if we zoom in close, we can see a big issue with that, which is that now we have a bunch of these super tiny triangles. I know I said that I wanted to go for irregular, but this is too irregular. Luckily, we can fix this by implementing Poisson disk sampling. I used Sebastian Lake's implementation, which worked perfectly for me. What the Poisson disk sampling does is that it simply places random points within a plane while making sure that the points always keep a minimum distance to each other. Now that that is done, we need to implement a function that allows us to manipulate the height values of our vertices' positions. We are doing that by iterating through all of our vertices and then layering the Perlin noise values depending on the amount of octaves we have set up in the inspector. Lastly, we are keeping track of a minimum and maximum noise height, which will help us determine whether a part of the terrain is water or not. And if it is, we are using a diminished height scale to make our water more flat looking than the rest of the terrain. Jumping back into the editor, we can now play with the values and create what is, in my opinion, a pretty decent looking terrain. The last thing we need to work on are the colors, of course, unless you are into the crumpled up church window aesthetic. We want to paint the triangles depending on height, so we need to calculate the average height of the triangle, which is simply done by adding up all the heights and then dividing by 3. In a switch statement, I added two different ways to decide on a color. The first one is the random setting you saw before, which simply generates a random color to return. For the second one, we are taking our terrain gradient and evaluate it by mapping our min and max noise height to 0 and 1, and then seeing where the current height would lie on that spectrum. Since we dampened our height in the shape terrain function earlier to make the water more flat, we need to undo that dampening before we can evaluate the color gradient. If we now switch to the height gradient setting, we can see our new terrain in all its beauty. We can change the gradient and play around with the values to create numerous cool looking terrains. And that is everything for this video. I hope you play around with this and create some cool looking terrains for your games. Feel free to share them with me on Twitter if you want.